Bismillahirrahmanirrahim. In this video we'll learn about solar panels and their positioning, whether it be adjustable is preferred or fixed panels are preferred. And sun is no doubt is a bounty from our Lord, and we must extract all the benefits possible from sun. Now, what is a tilt angle? We want that the sun rays should fall straight on the panel, and the angle that the panel makes with the ground is called tilt angle. Now, before proceeding, let's understand the solar paths in the different seasons. So this on the top is during June, when it's very hot and sun is almost on our head. Then in the autumn and spring, April or September, it goes down and the path is slightly lower than the that of summer. And similarly in the winter month it goes very low, and so this is the path followed by sun during the winter months. Now, 2 points that are important. One, it is said that for extracting maximum energy from the sun, our solar panel must face the sun and directly, so the rays falls directly on the panel. Now, if you look at this path, the sun is rising from here, so logically our solar panel should face the sun like this, and then when it is moving, then the panel should also face in that direction. When it is coming here, the panel should face in that direction, and like this. Now, this is the horizontal tracking. And also during the change in the summer, the panels should be either facing this one, or it should be facing this one, or it should be facing this. So this is like we had in the vertical, we are changing the angles. So the best way to get maximum from the solar is that we have a dual tracker. So dual tracker means this whole panel is moving towards east and then gradually to south, and then it turns towards west. So this is done once in a day, and this one is only seasonal, so this will be done 4 times in a year. So for every season it should be adjusted, but this one is daily. And you can see the mechanism for this is very complicated and expensive. So we, as a common man, should not opt for the dual tracking. Rather, we should opt for single tracking. And the benefits, of course, is if you have a dual tracking, you can see you get maximum energy as compared to no tracking or fixed tracking. And the difference of the energy level between the two is somewhere from 25 to 40%. And for single tracking also there is difference. Now you can see this is data from Phoenix, and so single tracking is giving us 2593 megawatt per year, whereas the fixed one is giving 2128. And so there's a difference of about 18%. So if we can't afford the dual tracking, we should be able to afford single tracking, and I'll explain to you how we can do that. Okay, now for commercial uses, this is one of the best solution, that you track it as the sun goes up from east to west. Your panel also turns, like panel is in this position when the sun is in the east, then panel is in this position when the sun is at the top, and the panel turns in this position when the sun comes here. So this is the best option. This is called azimuth tracking, and you can see that this panel is during the morning time it should be facing like this. This is almost noon time, so it is facing at the top, and at the sunset time or near sunset time it is facing the west. So this is the easiest way, and a small tracker or motor can be used, or even people where the manpower is in abundance, this can be done by manual changing the time after changing the axis or angle after every hour or so. So this will give you the maximum benefit. But for domestics, we can't use this. Not possible really, that every hour you climb on the roof and adjust. So for domestic, we should follow this option. That is, when in the winter months, the panel should face the sun, so it should be more elevated, like it is here. For the scenario of Pakistan, it has 56 degrees. And then during autumn or spring, April, September, now this is the line coming, so it should face that line. So at that time the angle should be around 32 degree. Now this angle is in between the two. Now let's see the third one. When the sun is up high in June, then the panel angle should be something like this, and in our scenario it is only 8 degrees. So these are the three possible adjustments that we should be able to make, and I'll show you what I have done in my house. So I have made this kind of an arrangement. This is hinged here, so the panel can be moved up and down. And I have three holes. One hole is here for 8 degree, here, or I think here, 8 degree, and this is for 32 degree, and there is a hole here for 56 degree. So 4 times in a year I have to adjust. So when in winter months I take this up here, so it becomes more kind of a vertical, and during the summer I bring it down, so it is almost 8 degrees or almost horizontal here. And if you see these angles, they are actually the autumn angle plus minus 24. So for winter we add 24, and for summer we subtract 24. So these are the three angles that one should be able to adjust. This will still give about 18% more than the normal flat panels. Another adjustment could be like this. So I have like angle irons. This is on the ground, and another one on which solar panel is mounted. So we have a couple of holes on this, and then a flat strip, 2 holes on 2 ends. So like this is connected. If I want to raise the panel high, then I'll bring it here, or I'll bring it here, so this will go high. If I want to lower the panel, then I'll bring this here, or even this can be adjusted here, and the other one goes like this, so this will come down very low. So this is how you can also adjust the panels for 3 seasons, seasonal variation. So let's talk about latitude, because this will be talking ahead. So latitude and longitudes are 2 imaginary lines, 2 sets of imaginary lines. The one coming from top to bottom or north to south is called the longitude line, and the one going around lines from north to south, these are called the latitude lines. And this is the equator, so the further away from equator it goes, the higher the latitude angle becomes. Now these are of course imaginary lines, you can't find it on the ground. And for any place, you can find out the latitude by going to this website and just putting the location. So I have put in various locations of Pakistani cities. Karachi is near to equator, so its angle is low, and Peshawar is further from equator, so its angle is high. I'm in Lahore, so Lahore angle is 31.5 or 32. Now, some people use a rule of thumb. They say that the best way that fixed panels should be adjusted at the latitude angle. So latitude angle in Lahore is 31.5 or 32. So they recommend that the panel should be fixed at 32. But I don't agree to their suggestions, because we can achieve or get more power if we adjust it, especially keeping in view the hot weather and where the demand of the solar energy is more. Now you can see this is a data from California, Los Angeles, California, and the latitude of California is 32 degrees, and the maximum people, that is 40% of the people, have aligned their panel between 11 and 20 degree and not 32 degrees. And about 25% have aligned their panels from 21 to 30 degrees, and then very low, very less number above 30 degree. Now, why has this been done? Because if you see from here, during the summer, this angle is low, like here it is 8 degrees, and the load is more in summer, so we want to extricate maximum power during summer, and that is why we want to keep the angle as close to the summer angle. So summer angle is 8 and autumn spring is 32, so the panel should be in between these two places to extricate maximum benefits, keeping in view the four seasons. Here is another data. You can see the place has a latitude 30.77, so according to thumb rule, the panel should be placed at here. But if you see the data, now at 10 degrees, 18 degrees, 26 degrees and 34 degrees, so during March it is the power is more at 26 degrees, but during June it is more at 10 degrees. At September it is more at 18 degrees, and December it is more at 26 degrees. So keeping in view our load requirement during summer, I would recommend that the solar panel be permanently fixed at around or between 10 and 18 degrees. So my recommendation is that the tilt angle for the fixed solar panel should be from 15 to 18 degrees. And for those who do not have the facility of measuring the angles, there is a simple mathematical formula that you can follow. Now this is the base and this is the height that we want for 15 degrees or 16 degrees, and this is where the solar panel is mounted. So if you know the base, which you know, I'm sure you can measure it. Let's say this is 100 centimeter, then we multiply the base by 0.3 to get the height. So when we multiply 100 centimeter by 0.3, it is 30 centimeters. So if you take the height 30 centimeter and the base 100 centimeter, so the angle that you get will be 17 degrees. So this way you can sight your solar panels on this. And one more advantage of low angle sighting, other than that we get maximum during the summer, is that during very windy season there is less chance of the panel to be uprooted. So I hope this video gives you some idea about solar panel tilt angle and sighting. If you like this video, please subscribe my channel. Thank you.